Hey everyone, I'm Josh Hugg. I'll be your primary instructor this semester for CS61B. Let's jump right in. Today, I'm going to basically walk us through what 61B is, and then we'll spend a lot of time talking about Java. I also have a co-instructor, Justin Yokota. He's not at my house, so he's not here in the video, but he will be there at live lecture later today. So I'm going to start off by just giving you a sense of what 61B is all about. We're assuming that you already are a pretty proficient programmer, and by that I mean you can build more or less anything given enough time. You've taken a class like 61A or CS88 or E7, and so you've seen object-oriented programming, recursion, lists, trees, that sort of thing. And so now what we're going to do in this class is transform you into somebody who can really truly have the faith and confidence in yourself that you can build anything, and to give you the tools to build software that can not collapse under itself under a big heaping pile of complexity. So I'd say that in a nutshell, the MacGuffin or the overarching theme to get there is to be thinking about efficiency. And that's efficiency in two flavors. One of them is the code's efficiency itself. How much time, how much memory does your code use? And often that boils down to using the right algorithms or data structures, as we'll see. But it's also about your efficiency, because after all, on any large project, the limiting reagent to an enterprise is the human time needed to make a thing happen. So we're going to show you how to use, for example, the Java programming language. That's one of the things we'll learn. That's not the focus of the course, but it's a language which has a number of features that are great for large-scale software. Another is we're going to see not just how do you write programs that are large, but how do you design them. And that'll be more towards the end, but thinking about what should be the classes, what should be the functions in those classes, that sort of thing. We'll also talk about software testing. So I'm going to try and wean you off of this autograder-driven development throughout the semester to allow you to write tests that give you confidence in your own code. And we'll also see how to debug in a more thorough and interesting way that you might have seen before. We're going to use some industrial strength tools like Git or IntelliJ or JUnit, although we're going to kind of hide JUnit, whatever that is, and a few other command line tools that might pop up from time to time. But the idea is I want you to use industrial strength tools so that ultimately you can do industrial strength work. Now, 61B is, in addition to all these topics, it has a sort of a context in the universe, which is, it is the class that teaches you a lot of the kind of things you get asked at job interviews. Things like hash tables, binary search trees, maybe someone might talk about sort of more esoteric things like skip lists. And we're going to equip you with the ability to answer those questions. Now, these foundational data structures and algorithms like, say, Quicksort, the reason they come up in interviews is that I always think of it as kind of like Greek or Latin in the old days when you wanted to apply to college. Like, everyone expects you to know it. It's the sign of an educated person. And here, these fundamental topics, they're just things people expect you to know. It's kind of a common language or a common problem space we can use to assess each other's knowledge, especially on the software engineering side of things. Now, even if you're not going to try and get a job in software engineering, I still think that having these skills is really useful, whether you're going to be a data scientist or a social scientist or whatever else. These skills are fundamentally important, and hey, it's nice that if you ever wanted to get a software job, you'll have a way to basically get your foot in the door. Another thing I really like about 61B is I think a lot of the discrete math structures of this class are really beautiful. For example, the idea of a resizing array, which we'll talk about later. It's a trick, basically, to allow yourself to build a list that can extend infinitely. Like, we'll unveil how Python lists are implemented in about 2 weeks. We'll talk about, for example, the isometry between self-balancing 2-3 trees and self-balancing red-black trees. I know it's a little jargony, but it turns out to be a really beautiful idea. It's a lot of little connections between things in computer science that could be a little subtle. We'll talk about graph theory, compression theory, complexity theory, which up here I've called asymptotic analysis. And I find a lot of this math really fun. I'm usually actually more of an integrals guy. Like, that's the kind of math I like. I like continuous spaces, I like signal processing. But 61B's flavor of discrete math I find pretty fun. And then, of course, as I noted earlier, one of the big takeaways, one of the big reasons to take this class is I really want you to have this confident sense that you can really build anything. Okay. Now, if we were in a real-life room, which I will be later today, I would ask what you hope to learn from this class. I'm not going to do it here because you are watching me a video. I would also maybe ask who you are, but again, can't do it online. But hey, I have that pre-semester survey. If you haven't filled it out, please do. I always like to know roughly the components or who comprises the class. Like, for example, I learned that 98.5% of you have written code in Python, which helps inform a lot about how we teach. And lastly, I'll say a little bit who we are. So I'm Josh. My co-instructor Justin is going to be a little more behind the scenes, doing a lot of things along the lines of writing exams and pushing forward some features of the projects. And then, of course, we have a massive team of GSIs and tutors and academic interns that are crucial to support us because we have 1,775 people enrolled. So that's 61B in a nutshell. So next we'll jump into, in the next video, some logistics.